Good morning. This is Dr. Jingbo Louise Liu from Texas A&M University Kingsville, the Department of Chemistry. I'm also affiliated to the Texas A&M Energy Institute. So today I'm very delighted to show you about my research efforts. So essentially I'm working on two different directions. One direction is energy related. The second direction is biomedical related. Regarding the energy-related research, I'm particularly focusing on the catalyst used for the solar energy and photovoltaic. Particularly, I'm working on the metal oxides and its energy band gap evaluation. The second group of energy study is about the electrocatalysis used for fuel cells. Regarding the fuel cells, so our group and our collaborators working on solid oxide fuel cells, hydrogen proton membrane fuel cells, so proton exchange membrane fuel cells, and also microbial fuel cells. The third part of research related to energy is about photocatalysis. Particularly, we try to minimize the energy consumption and convert wastewater or purify wastewater and convert some waste materials to the value-added materials. The second group of research is about biomedical field. So this is in collaboration with Professor Sajid Bashir Liu and also the professors from pharmaceutical energy and the Dr. Weigel, Dr. Jose, and Dr. Patrick from the U.S. Air Force. So to enhance this different biological related work. Particularly, I want to mention two. One is a nano-disinfection. Nano-disinfectants involved in three different generations. The first one we considered as the metal nanoparticles. The second one is metal and metal oxide nanocomposites. The third one is related to high porous materials such as zeolite, such as metal organic frameworks. The second group of research is related to the cancer theranostics. And also we have two major different groups of materials I'm mainly focusing on developing. The first one is called metal organic frameworks, particularly is Fe ion-based frameworks. The second group of materials is gold-based nanoparticles. We use different ligands, different say natural products to do the modification. So we are essentially forming a nice core shell structure based on the end application. So since 2016, we start working with the Kleberg law enforcement, the local law enforcement, developing in two different groups of research. The first one, we developed something called coordinative organometallic polyhydrins. We call the COPs, COP, as the fingerprint development agents. The second one is more personal favor, is about the unmanned automated vehicle. I did fly a little drones quite often. I want to show everybody a little bit more about the opportunities, especially the detailed research efforts in the following couple slides. First of all, you want to understand the nanostructures. We are going to use a different equipment, such as this is called the X-ray powder diffraction data. And this part, especially when you determine the energy band gap, we use a soft X-ray synchronous method. It's called photon in and photon out, soft XAS and XES. In this little corner, this graph is called transmission electron microscope, particularly for the morphology analysis and for the single crystal energy electron diffraction patterns and ring patterns to determine the fine structure of the nanomaterials. Another types of research is more focusing on the such as hydrogen storage, carbon dioxide capture, and also electrochemistry analysis about fuel cell and solar cell related work. So we showed you this is a power density, current density plot. This is called cyclical photometry, and based on the different study, you want to understand the stability for the fuel cell operation. Whether they have long-term stability is also very critical. Our driving force is try to improve the onboard hydrogen storage, and also recently we are working with an engineering professor to do something called water electrolysis. That's a future study. Again, we are going to measure the power density, the current density for the different application of fuel cells. So we do know there are several important goals for your hydrogen storage, such as at 2010, so you need to reach 4.5%. Fortunately, this value has been already achieved, and eventually, so Dr. Zhou's group has been reached 7.5 weight percentage. The second direction about my nanomaterials application related to the nano disinfection and cancer diagnostics. So this diagram essentially showed you some different mechanistic study about how the nanomaterials is going to be targeting to treat or diagnose that cancer, particularly cells. And we also did the cell variability analysis, the transmission electron microscopic analysis, also some atomic analysis. So this project is a teamwork, so also supported by the different funding agencies. Particularly, I want to mention the Welch Foundation and also the U.S. Air Force support, and the National Science Foundation, so Japan's Society for the Promotion of Sciences, the Academia of Mexico support, and also the U.S. Air Force support. Particularly, more importantly, is Texas A&M University and Texas A&M University Kingsville support. Thank you so very much for listening. Stay safe and stay healthy.